Hello everyone, welcome to this problem, minimum number of changes to make binary string beautiful. So what you receive here is actually a string with even length. So you are giving a 0 in this binary string as having an even length. Okay, this is actually a fact. Now, a string is beautiful if it's possible to partition it into one or more substrings such that each substring has an even length and each substring contains only 1 or only 0. So let's say you receive this as input. If you split this at 1 with the 1 0 and the other one with 0 1, the substring are not beautiful. But for them to be beautiful, you need to either have 1 1 here or 0 0 here and the same on the side. But there's one thing here, you can change any character in S to 0 or 1. Return the minimum number of changes required to make the string beautiful. So let's say I receive this as input. Let's say we just have this as our string as input. For it to be beautiful, I need to change this. So I can decide to change this into a 1. And if I change this into a 1, this one is now beautiful because this one is of length 2. And if you split it, you are going to have just one possible split, and it actually respects the condition of being beautiful. If now my string consists of this, this will not respect, because if you split this and then this sub part will not respect the condition of having the same element. What do I mean by having the same element? Each substring contains only 1 or only 0. So if you split this, it will not work. So for this one to work, you need to change this also into a 1, or you can change also this into a 0, it depends. And let's say if our string was to end here, the solution will be 2 because you apply 2 changes. But let's say if you have a string again going up to here, there's nothing to change here because this is actually valid. Now this one, you can also change this one into a 0. That is actually 3. My string is not even correct. This one into this one, there's no change to do. And this last one, let's say we have a 0 here. If you have a 0 here, so there's nothing to change. For this input, the answer is going to be 3. The answer is going to be 3. So now, given this, how are we going to solve it? For me, my idea is that since the smallest possible split you can have is actually 2 elements, that actually indicates to me that any 2 consecutive elements starting from the first element are going to be in the same substring. This one and this one are going to be in the same substring. And if they are going to be in the same substring, then this one and this one should be valid. And for them to be valid, if the values are actually different, then I need to perform a 1 switch for them to be valid. So that will be the idea. So I will loop 2 by 2 and I will check. If they are not valid, I just increment my counter. That means the number of switch I need to perform. So what will it look like in code? In code, I'll have something like in result that is going to be 0, and this is the guy I will return here. And in the loop, what I will say is I will say for I is less or equal to I is less dot s dot size I plus equal to 2. So I don't really need to go one by one, because if I'm after being here, the next step I want to move is here, because I'm checking 2 by 2. So what is happening is that I need to check just if s of I is actually different from s of I plus 1. Then I just need to make result plus plus. Let us run. Okay, we have one error. What are we missing? We are moving from 0. S of I. What is this? Different from S of I plus plus. It was in a good place. Okay, working. Perfect. Let us submit. Perfect. Performing Very well. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new challenge. Ciao.